All right, everyone. Thanks for joining me this morning. I know it's early. Last week, we started going through the Kubernetes The Hard Way labs. We created a certificate authority. We signed a whole bunch of TLS certificates and generated a whole bunch of 2048-bit encryption keys. We provisioned our networking on Google Cloud, and we provisioned our VMs on Google Cloud. This morning in session 2, we're going to configure a whole bunch of configuration files using kubectl. We're also going to start building our stuff out. We're going to bootstrap etcd. We're going to configure etcd on our control plane nodes and talk a little bit more about what etcd actually is. So let's get straight into it. All right. So lab session 2, we'll hop over to the docs page here in just a second. The docs page URL is right there on the top of your screen. Hopefully everything should be working. Links to the other sections. All right. So first and foremost, I'm going to go ahead, and this isn't in the docs. I must have forgotten to put it in there. I'm going to go ahead and hop over into my Google Cloud Shell. Let's go ahead and do that. Control R. All right, this is going to take just a few seconds for it to provision a new instance for me. And because every time I start a new Cloud Shell machine, it is a brand new machine, I'm going to have to log into my G-Cloud account and do that stuff. It's only going to take a couple of seconds. Should have done this beforehand. Excuse me. And go. It always feels like it takes 10 years when there's a camera on your face. All right, while we're waiting on this, let's take a quick stroll through the docs. Talk about what we're going to do this morning and see how long it takes. Hopefully, we should be able to knock this out in 45 minutes or so. So we will go ahead. We're going to need our Kubernetes public IP address to put in our configuration files. We'll configure files for our kubelet. And it's kind of cool. And I'd forgotten about this until I started to go back and do these labs again. All of the configuration files in Kubernetes, so all of the files for kubelet, all the files for all the control plane instance services, all that fun stuff, they're all actually configured with kubectl, which to me is pretty cool. Kubectl is not just that thing that you use to look and see what pods are running in which namespace. It's not just that tool you use to query the database. We're actually using it to configure things. And our Cloud Shell instance is just about up and running. I've got some scripts that run at the very beginning of it. So we'll hop back to here. There we go. I'm going to go ahead and initialize. We did this last week. Go ahead and open this up. Oh, it missed a little bit of it. There we go. All right, I'm just doing this in a browser off screen so you don't have. All right, enter project ID, Kubernetes The Hard Way, JDuncan prod, which is the project I'm using for this. All right, we'll go ahead and set a default region and zone. I'm going to be using number 6, US East 4A, which is where I provisioned everything last week. vCloud compute instances list, make sure that works. And there they are. There are our nodes from last week. Awesome. All right, so let's go ahead and get to the beginning of this. Looking through the docs, first thing I need to do is grab that public IP address. Go ahead and clear this to bring it to the top of the screen. Kubernetes public IP address, and I'm just using the G-Cloud command to get this squared away. All right, make sure that worked. All right, just like it was last week. Now, the first thing we're going to do is create the configuration files for our kubelet instances on our application nodes. It's a big for loop, like we used a couple times last week when we had to create multiple certificates at the same time. It's nothing too complex. If we want to take a quick look at it, for instance in worker 012, so those are the host names we're going to be configuring. kubectl config set cluster, Kubernetes the hard way, that's what we'll be naming our cluster. And then we start referencing these files that we created. ca.pim, embed the certificates is true. So this certificate author this is our certificate authority's key. So this is saying everything that we talk about inside our cluster should be signed by this certificate. The server is going to be that public IP address on port 6443. Remember last week with the firewall rules, we opened up 6443 for the Kubernetes API server. Kubeconfig file equals our instance name.kubeconfig. And then we're going to go ahead and set credentials for the system node worker 0. And this is how the kubelet on each of the nodes actually authenticates to the servers. So this is how when we send the kubelet sends a command in, it says, all right, this system node, my host name user, here's its certificate. And then the services all verify that that's correct using this stanza from the config file. So client certificate is instance.pim, so worker 0, worker 1.pim. Those are the ones we created last week. The same for the key, so using those files we created. And then the kubeconfig equals our file, our instance.kubeconfig. And then we'll set our context to default, so we'll be doing this in our default namespace, which is just sort of how it works. Define our cluster, set a system node user. So we're defining our users in our database for all of our hosts. Awesome sauce. And then we're telling it to use our default context. So if we hit enter, got a big old error. Oh, because I'm not in the directory. There are all of our files. So let me run this loop one more time. All right, and we see a whole bunch of things. So cat worker 0.kubeconfig. Here's all of our stuff. So all of those commands just created all these things. And when you look at it, it's a whole bunch of certificates that got embedded into a file. API version v1, clusters. Here's our cluster config. So here's our cluster CA, the server, the public IP address we just grabbed, the name, our default context, the certificate to use for all of that. So these are the kubeconfig files that will go on each node to communicate back to the API server. And we actually used kubectl to do that. I just think that's pretty cool. And we're going to do the same thing for kubeproxy. Go ahead and clear out my screen so it's not too confusing. And kubeproxy, we only need one config file because we'll put the same config file on each of the nodes. And we're doing the same thing. We're saying here's our certificate authority's key. We're saying here's our server address for the certificate authority for our cert. Here is the cert for our kubeproxy service, and then here is the user to communicate to using this certificate to this server for kubeproxy. Enter again. Cat kubeproxy kubeconfig, and it's the same thing. So again, what we're saying here with this command, we're saying here is the certificate for our server, and our server is at this address on port 6443. And then we're saying here is the certificate for the kubeproxy service. Here's the key for the kubeproxy service. And then here is a system user, a system account to use the kubeproxy service, for a kubeproxy service to use to communicate with this server. So it's getting all that squared away. We're going to do the same thing for kube controller manager. If you'll notice, this gets pretty repetitive, which isn't the most fun thing in the world. But as I do these, as I was working on this last week, it became kind of startling to me how Kubernetes was designed to be easily automated. I just think that's awesome. Because a lot of times you'll see this technology, especially something that, can spread out to thousands of nodes in a cluster. You really have to sort of shoehorn in automation and verification. Kubernetes was designed that way from the outset. I think that was one of the strokes of genius for the people that invented it. All right, so go ahead and create our controller manager kubeconfig file. Make sure that got created. Kubecontroller manager.kubeconfig. All right, that's all there. We'll create the same thing for kubescheduler. All right, again, here's our server and our server certificate. Here is our service, kubescheduler, and our services certificate and key. And then here is our user for the service. So it chains all the way back up, so we can fully trust that everything we do is fully encrypted. There's all that. And then we'll create an admin user. And this is doing the same thing. This is specifying our certificate for our cluster and where to talk to our cluster. But there is one difference. You notice here under server, it's not our public IP address variable, it's the loopback. It's 127.0.0.1. This is the system user that Kubernetes itself uses. So this is a system account. Excuse me. This is our admin user. So system:admin. Right. Done and done. And then we need, this is a little bit out of step here. This is a little bit of YAML. The last thing we need to do here before we actually bootstrap etcd is we need to create some YAML for an encryption config. And the encryption config is what we use to encrypt data inside Kubernetes, so data that's encrypted at rest. You notice the first thing we do is set an encryption key using a 32-bit random, so 32 characters out of dev random, and then we encode them as a base 64 string. Not the most secure thing in the world, but it's what we use just inside the cluster. And then the YAML for the encryption config.yaml is just YAML. It's an encryption config object for Kubernetes. We're going to use this down the road a little bit. Just make sure that happened. Cat encryption config.yaml. There we are. Here's our base 64 encoded 32-bit random string. All right. Those are all the config files we have to create this week, which is awesome. So we need to distribute them over to the right servers. So for worker 0, for all our application nodes, we will SCP over the instances kubeconfig. So it's unique kubeconfig for the application node, the config for kubeproxy, and then that encryption config YAML as well. Again, just another little for loop. And this should happen 3 times. All right, that's done. And then we need to take our kube configs, for our control plane nodes and move those over. And that's the admin.kubeconfig, kube controller, kube scheduler, and then, yeah, that's it. So kube scheduler, kube controller manager, admin kube config. And then we'll move all those over. Which again should happen 3 times. Now that's all the files, that's all the repetitive work we have to do. Now we have to alter our screen just a little bit because we're going to actually get into a tmux session and configure our systems. So I need 3 panes in for tmux because I want to do this the same way 3 times. I don't want to have to copy and paste 3 times for 3 servers. So we'll get into a tmux session. All right. And then Control B double quote, Control B double quote. So I now have 3 panes in my tmux session. And then Control B : select layout space even vertical. This will space everything off nice and easy, so it looks the same each way. Good to go. All right. Now I need to connect to each of my controller nodes. So each of my control plane nodes. And I need to do that each in one of those 3 sessions. So Control B, the up arrow moves me up through the panes, down arrow moves me down through the panes. I'm going to use the gcloud compute SSH command. Controller 0. Packet type. Oh, well, here's the first thing I forgot. Because these are each a new session, at least in the Cloud Shell, I haven't tested it in like just a normal instance, but in the Cloud Shell, I've actually got to run gcloud init for each one of these. A little time consuming, a little annoying, I know, but better safe than sorry. All right, I want to go ahead and log in. This is just going to take me a minute or so. Allow. Copy. All right. Enter our project ID. Kubernetes The Hard Way, J. Duncan prod. And I want to use region 6, which is US East 4A. And there we go. All right. I'm going to go ahead and do that for all 3. gcloud init. I wish there was a way I could do this ahead of time, but there isn't without a whole lot of extra rigmarole. But doing a little bit of this on the front end is way easier than trying to do the same thing 3 times in a row on 3 different servers. Tmux is certainly an admin's best friend here. Kubernetes The Hard Way, J. Duncan prod. Yes. Number 6. Right, that one's done. And the last one, Control B down. gcloud init. 1. Yes. Almost there. Excuse me. I wish there was a way I could do this purely on the command line, and there kind of is, but I have to open a browser window regardless to get logged in. Kubernetes The Hard Way, J. Duncan prod. Yes, same region. All right, now I'm logged into all 3 of my Tmux panes, which is awesome. Now I can connect to Control B+, Control B+. So gcloud, compute, SSH, controller 0. Now I'm in controller 0. gcloud, compute, SSH, controller 1. I'm in controller 1. And gcloud, compute, SSH, controller 2. All right. Now the cool thing about Tmux is I can turn around and take these 3 sessions and I can synchronize them. So Control B, set W, synchronize -panes on. And if I type a command in one, I've typed the command in all 3. So now I can do the same. I can even copy and paste here, and Tmux will send those commands in parallel out to all the instances that I'm connected to. All right, now let's go ahead and configure etcd. And we're going to do the same process in session 3 when we configure our application nodes. So anytime we need to connect to the control plane or the application nodes to do some sort of configuration, we're going to use the same Tmux setup. For session 3, and I'm 98% sure we have to use it for session 3, I'll go ahead and do that ahead of time just to make this go a little smoother so we get to the fun stuff and not just watching someone log into GCP 3 times. So the first thing we need to do to configure etcd is pull down the binaries. So the binaries are out on GitHub. So they're, a tag release. We're going to be using etcd 3.4.10. And we hit enter and we pull it down. It's not very big. We extract it. Just tar-zxf or xvf. Done and done. And then we move the binary, or there are multiple binaries, to user local bin. All right. Which, if I could type, which etcd, user local bin etcd. So we know we have it there. Now we have to take those configuration files that we just shuffled over to the controller nodes a few minutes ago, and we need to put them in, in the right place. So I'm going to make a couple of directories, /etc and /varlib etcd. These are just used by the system. That's done. I'm going to make varlib etcd executable by just the root user. Then I'm going to copy varlib etcd is where a bunch of generated config files go. The actual certificates and kubeconfig files that we're going to be using are used in /etc etcd. There we go. So copy our CA certificate, our Kubernetes key certificate, and our Kubernetes certificate. So the Kubernetes.pim is for the API server, and Kubernetes key is the corresponding key to /etc etcd. Now, and if you're looking over on the docs page, we're in step 4 for bootstrapping the etcd cluster. So get the host internal IP address. Go ahead and copy that over. Internal IP. So instead of using the gcloud command, because we're actually on the servers, we're hitting the Google metadata server at metadata.google internal, and we're getting the IP address for interface network or interface E0 or interface 0. There we go. Make sure that worked. Internal IP. There we go. And then we also need to set a variable for our etcd name. Remember, this is that same etcd name that is referenced in our configuration files or in our certificates. The certificate has to be that worker-0, worker-1, the short host name. So command V, etcd hostname equals hostname-s. Echo etcd name. Controller2, controller1. All right, so that's good to go. And we're going to be starting this thing with systemd. So we're going to create a systemd unit file. And it's not going to scroll because I've got 3 panes and I want them to show up all the way on the YouTube live stream. It's not going to look very pretty. So we're going to hop over to the docs page and look at this first. It's a little easier to see here. So it's in step 6 of bootstrapping etcd, create the etcd service systemd unit file. And the file will live at etc systemd system etcd.service. And then it's just a unit file. If you've ever dealt with systemd, this should look pretty familiar. It's just defining where all the different certificates and keys and files and things that etcd needs for it to start effectively. So we'll paste all of this into our terminal. Again, it doesn't look very pretty there, but it should work. And just to make sure, clear head-n5. All right, there's our file. So we know it got created. Excuse me. And then we start. We'll start etcd. CTL daemon reload just to recognize all the new service file. We're going to enable this guy. So he will now, etcd will now start at boot. And then cross your fingers. Hopefully we just started etcd. CTL status etcd.service. Looks like it's running. Active running. We look good there. But we can also actually run etcd-ctl, which is etcd control. All we have to do is feed it the certificates that we need it to use from our config file, and we can actually use etcd-ctl to query the server. And we have a 3-node etcd cluster up and running. All 3 are started. They all have the proper etcds available at ports 2379 and 2380. Everything is up and running. So this is going to be a short week. I don't see any questions in the chat. What we've done today, so what we did last week, just to walk through cumulatively, we pulled down some files. You know, we're using Cloudflare's SSL tooling. We're using kubectl from and all the other tooling we pulled down last week. We created a VPC. Go ahead and get to the screen. We created a VPC. We created a network on that VPC. We then created our application nodes and control plane nodes. We then created a whole bunch of TLS certificates and SSL keys or TLS keys for our systems. And then today, we created a whole bunch of kubeconfig files for our various services to use that reference all those certificates. And then we move them to the proper, either the application nodes or the control plane nodes. And then we bootstrapped etcd. So we were able to put the files in place for etcd to function, pull down the binaries, create a systemd service file so the system would actually start, and then start etcd and verify through systemd and through etcd-ctl that the application is running. I think that's pretty awesome. So next week, we get to turn our cluster into what looks like Kubernetes that we all know and appreciate. We're going to configure all the services on our control plane, get all of those up and running, get all the firewalls set up, get everything squared away. We're going to configure the services, so configure kubelet and kubeproxy and our container runtime on our application nodes, and then also configure kubelet, kubectl, so we can use it remotely. So configure our control plane so kubectl on our laptop can talk to the API server and get information. So kubectl get pods and point it at our cluster. So configuring kubectl for remote access. That's all going to be next Monday or Tuesday. If you've got any questions walking through this, give me a shout on Twitter, give me a shout on email, however you know how to get a hold of me. Google chat internally at Google or whatever externally. I'm pretty easy to get a hold of. And thanks for the time. And looks like we came in right about 30 minutes here. So if you've got any questions, give me a shout. If not, have fun configuring etcd. And take a look when you're using kubectl, and it's way more powerful than just pulling pods and editing deployments. It's a really cool tool. All right, y'all have a good rest of your day. Thanks a lot.